Welcome to our motion chapter revision. In this video, we will explore the fascinating world of motion as described in the Class 9th science book. But before we begin our journey through the world of motion, let's ignite our curiosity with a question. Have you ever wondered how rockets soar into space, or how birds gracefully glide through the sky? It's all about motion! Motion. In physics, motion is the change in position of an object concerning its surroundings in a given period of time. It's when an object moves from one place to another. Types of motion. Motion comes in various forms. There are three main types. Translatory motion. Imagine a car moving in a straight line on a highway. This is translatory motion. It's when an object moves in a straight path. Rotatory motion. Now picture a spinning top or the Earth rotating on its axis. This is rotatory motion. Objects rotate around an axis or point. Vibratory motion. Think of a pendulum swinging back and forth or a vibrating guitar string. This is vibratory motion. Objects move back and forth around a central position. Example, as we now understand, a car moving on a straight road, translatory, a spinning top, rotatory, and a pendulum, vibratory. Distance and displacement. Now, let's talk about distance and displacement. Distance, it's the total path traveled by an object. Imagine taking a walk in a park, the path you cover is the distance. Displacement, this is the change in position, and it has both magnitude and direction. If you start at point A and end up at point B, your displacement is a straight line from A to B. Example, if you walk 10 meters to the east and then 8 meters to the west, your displacement is 2 meters to the east. Speed and velocity. Let's move on to speed and velocity. Speed, it's the rate of change of distance. For instance, if you travel 100 kilometers in 2 hours, your speed is 50 kilometers per hour. Velocity, unlike speed, velocity considers both magnitude and direction. So, if you travel 100 kilometers to the north in 2 hours, your velocity is 50 kilometers per hour to the north. Example, a car driving at a constant speed of 60 miles per hour. Acceleration. Now, acceleration, the rate of change of velocity. Positive acceleration, when an object speeds up, like a car accelerating on a highway. Negative acceleration, this is when an object slows down, like a car coming to a stop. Zero acceleration, when an object maintains a constant velocity, like a car cruising at a steady speed. Example, a car accelerating from 0 to 60 miles per hour in 10 seconds. Equations of motion. Equations of motion help us describe how objects move. There are three of them. 1. V is equal to U plus AT. 2. S is equal to U, T plus 1 by 2 AT square. 3. V square is equal to U square plus 2 AS. Example, solving for the final velocity of an object given initial velocity, acceleration, and time. Graphical representation. Graphs can be powerful tools for understanding motion. Distance time graphs, these show how an object's distance changes with time. Velocity time graphs, these reveal how an object's velocity changes with time. Examples, visualizing constant speed and acceleration on graphs. Uniform and non-uniform motion. Objects can have uniform motion, where they cover equal distances in equal intervals, or non-uniform motion, where the distances covered are not the same in equal intervals. Example, a car maintaining a steady speed on a straight road versus a car stuck in traffic with varying speeds. Scalars and vectors quantity. In physics, we have scalars and vectors. Scalars, these have only magnitude, like speed. Vectors, these have both magnitude and direction, like velocity. Example, speed is a scalar because it tells us how fast you're going, but not which way. Relative motion. Motion is relative to the observer's frame of reference. Imagine two cars on the highway. Their relative motion depends on whether you're in one of the cars or watching from the side. Example, the relative motion of two cars on a highway. Uniform circular motion. Finally, uniform circular motion. This is when an object moves in a circle at a constant speed. Think of a car on a roundabout, it's always moving but not in a straight line. Example, a car going around a circular track. That concludes our revision of the motion chapter from the Class 9th Science book. We've covered distance, displacement, speed, velocity, acceleration, equations of motion, graphs, types of motion, and more. Now, it's time to pick up your books, dive into those problems, and embark on your own scientific adventure.
Thank you for joining us in this motion chapter revision. We hope you found this video helpful. If you did, don't forget to like and subscribe for more educational content.